What's good, math family? In today's EOC video, we're looking at graphing absolute value functions by transformations and using a table. So when we start off, we have to know the standard form or the general form for absolute value functions, which is y is equal to a times the absolute value of x minus h plus k. And we have to remember that hk represents our vertex. So our vertex for this absolute value is going to be at -4, -3. So from the original graph, right, whose vertex is 0, 0, we're going to move by transformation to the left 4, down 3. So this is our new vertex. And then we could draw a V. But let's say we're trying to get exact points. When we look at the original graph, remember there's a slope of 1. So our points are going to be, our x's are going to match our y's. So this is 1, 1, 2, 2, and so forth, right? Because we went up 1, over 1. However, with this a, we have a rise over run of 2. So to get to my next point, I could go up 1, 2, over 1. So my next point would be -3, -1. And remember that the vertex is like the axis of symmetry. It flips it in half, right? So there's another point that matches this one, which would be -5, -1. Now we could follow this slope pattern and make even more points if we want to, or we could use these 3 points and we could just finish off our graph and draw our V. But let's say we wanted exact points and we didn't trust this method. What else could we do? We could create a table. So let's test these 2 points to see if those actually work, right? So here goes our x, here goes our y. We know we have -4, -3. We're going to do -3, -2, and -5, -6. And just remember, family, -3 and 5 are going to share the same y, and -2 and -6 are going to share the same y. So when I now go in and I substitute in the original equation, right, let's say we do 3 first. We have y is equal to 2 times the absolute value of -3 plus 4 minus 3. When we simplify this, we get y is equal to 2 times the absolute value of 1 minus 3. So we know y is equal to 2 minus 3, which means y is equal to -1. So remember, -1 for 3 and -1 for its adjacent point, right? We already had those points, so we know those are accurate. Now let's say if we wanted to get another point. So let's say we go and we plug in 2. So now we have y is equal to 2 times the absolute value of -2 plus 4 minus 3. So we know y is equal to 2 times the absolute value of 2 minus 3. So we know y is equal to 4 minus 3. So we know y is equal to 1. So we could put +1 here and +1 for 6. Now let's just go over here and check. So when x is -2, right? So we're at -3, 1. I go up to 0. I go up to +1, and then I go over 1. So my next point would be -2, +1. I know my graph's off, but it's just a sketch. Okay. So now let's say we're trying to figure out other points. So what if they asked us for the y-intercept? Yes, it's absolute value, but just plug in what? If you want to get your y-intercept, make x 0. So y is equal to 2 times the absolute value of 0 plus 4 minus 3. So we know y is equal to 2 times the absolute value of 4 minus 3. So y is equal to 2 times +4, which is 8. 8 minus 3 is 5. So I know the y-intercept, right, is going to be at 0, +5. Now let's say I wanted to figure out where does this absolute value cross the x-axis. This is how we're going to do that. So what we're going to do is we're going to make y 0 now. So when y is 0, we still have to follow the rules of absolute value to solve. So what does that mean? We need to get absolute value by itself. So we add 3 on both sides. We have 3 is equal to 2 times the absolute value of x plus 4. It's still not by itself, so we divide by 2. So we know 3 over 2 is equal to the absolute value of x plus 4. So now that we know that, we can now create the two equations to figure out what is our x-intercepts. But let's get some space first. So let's erase some of this. So my first equation, we have the absolute value of x plus 4 is equal to 3 over 2. When I drop it, we have x plus 4 is equal to 3 over 2. I subtract 4 to get x is equal to 3 over 2 minus 4. So remember, if we want to have the same denominator, 8 over 2 is the same thing as 4. So I'm going to switch my denominator to 8 over 2. Now at this step, x is equal to negative 5 over 2. So this is my first 0, right? So my x-intercept is negative 5 over 2, 0, and then we're going to get our second one. So for the second one, all right, let's switch back to red. We have x plus 4 is equal to negative 3 over 2. So now once I subtract, I have x is equal to negative 3 over 2 minus 8 over 2. Combine my numerators, x is equal to negative 11 over 2, and this is going to be my next x-intercept. Okay, so now before we wrap this video up, we've got the vertex, we've got the x and y intercepts, we know how to find other points. So now let's talk about key features of the graph. Okay, so if they ask us for the domain, we should know all real numbers. If they ask us for the range, right, we know that y is greater than or equal to negative 3. If you express it with interval notation, because that answer is included, we have a bracket, negative 3 to infinity. Now, the last thing that they're going to ask you is about the intervals of increasing and decreasing. All right, so let's put increasing and let's put decreasing. And just remember, this is going off the x coordinate for the vertex. So this is what I mean. This is going to be increasing what? Hold on, let's make sure. Okay. When it's going to be increasing between negative 4 to infinity, right? And then we know it's going to be decreasing, meaning our y values are getting smaller on the left side when we're coming from negative infinity all the way up to negative 4. And I'm sorry, both of these should be parentheses, not brackets.